last time was discussing the liquid level control, and simply the process under control was to achieve certain level inside the tank. And we stated that if this is the tank, and let's assume I will change slightly the last example, such that I'm allowing the liquid to flow out from the tank. And for that, I will use an outlet valve. And this valve is adjusted such that certain flow, let's say Q out, will be flow out from the tank. So this is the outlet flow rate. And we need to control the level inside the tank to be at certain level. Let's assume that we agree to choose this level as the desired level. So this is my desired output or desired level. So here, if we recall the basic elements of control system, who remember it? The first one was what? The process. So the first one is the process. And simply the process we defined as what? The object to be controlled. The object to be controlled. And in this case, what I'm controlling, ask yourself what I'm controlling here.
Liquid level.
The liquid level. So simply here I'm controlling, let's say, the level of the liquid. Okay. Please mute yourself. Huh? Only if you need to ask question, or if you need to answer my question, enable the speaker. Otherwise, I will all of you will hear the echo actually. So simply this is a very simple and very important, because you should understand what you are controlling. Yes, simply ask yourself what I need to control. I need to control the level of the liquid inside the tank. So this is the process. So the second thing, we stated that the process by itself cannot change, correct? Can the liquid flow inside, let's say, the tank by itself? No. So simply what I need an actuator. So simply the second element is the actuator. And the actuator we defined as what? Is a mechanism to provide the power to the process, or in order to put the process into automatic action. So simply here, a mechanism, let's say, to put the process into automatic action. So simply I need now an actuator. What do you think I can add here an actuator?
The valve.
The valve can be. So what about, to make it more interesting, I will introduce pump. Okay. So simply here I need to control the inlet flow, the flow rate inside the tank. And let's assume that this one is the QN, which is the inlet flow rate. And I need to control it using either the valve, let's say, but simply valve, I need one to regulate it. Let's make it more interesting, and I will add here what? A pump. You know the pump, huh? You know the pump?
Doctor.
Yeah. And simply because you are electrical engineer, I will assume that this pump can be controlled by electrical signal. And of course, most of the pumps are controlled by electrical signal. And let's assume for simplicity, this is the plus and the minus. So simply here, I'm controlling the flow rate by the pump by controlling the voltage, correct? Logic? Yeah, it's very logic. Let's assume that this pump supports a flow rate between 0 to choose. Who will choose? 20 liter per minute, 100 liter per minute? Any number. Let's say 20 liter per minute. Fair enough?
دكتور ما اعرفش اذا عندي بس ولا عند الكل الشير سكرين راحت.
الوايت بورد راح
عند الكل اتوقع انه برضه عندي فصل
عند الكل دكتور.
Just now.
تمام دكتور.
تمام دكتور.
Actually, today I decided to give the lecture inside my office, and maybe this is one of the biggest mistakes. So simply before I did that in my house, whatever, but now I think the network is stable. I hope so. Okay. So now let's assume that the pump can support between 0 until 20 liter per minute. And this is actually the physical system put this constraint. And this is fair enough. Huh? For example, let's assume that this pump can support maximum flow rate to be 20 liter per minute. Yes? Good. So now in this example, the actuator is the pump. Yeah? Of course, if I'm adding here, instead of the pump, a valve, then the actuator will be the valve, correct? Yeah? Okay. So now what I'm controlling? Actually, I'm controlling the process and the pump. I'm controlling the process by controlling the pump, correct? So simply now, if I'm draw a block diagram or a description, let's say, for the process, and you know that the process is actually a system, which means that it has an input and output, correct? This is the process. And we know that the output from the process is the actual output, correct? Which is the here what? The actual level, huh? The output of the process is the actual level. And in order to put the process into automatic action, we need what? We need an actuator. So this is the actuator. Now the output of the actuator is the input to where? To the process, correct? The same thing, the actuator is a system, which means that it has input and output. Now, if I'm asking you, what's the input to the actuator?
Desired height.
Desired
liquid level.
No, the actuator is what? The pump, correct?
Desired flow, speed.
So the input to the pump is voltage, correct? Yeah. The output from the pump is what?
Speed.
Is the flow, correct? Yes. And the flow will enter to the tank in order to change what? The level, correct? Yes?
Yes.
Good. So now, the actuator by itself, the pump, can know how much voltage it needs. Simply, it's the device, and the device is waiting for a voltage to be imposed to the device, correct? So this will open the door for the third element in the control system, which is the controller. Huh? So the third element is the controller. And do you remember last time we defined the controller to be what? Hmm?
Human.
Human.
Now, last time it was human. Here actually I'm having pump, huh? And the pump now by itself cannot think, by the way, huh? Now the controller by definition is a mechanism to tell the actuator what to do. Yes, it can be human, it can be microcontroller, it can be another system, correct? So simply the definition of the controller is simply a mechanism to tell the actuator what to do. Until here, I don't have controller, by the way. I'm not plotting the controller, yeah? So now let's assume that all of you said human, huh? So let's assume that here we have the engineer, and simply the engineer is adjusting, let's say, the supply in order to control what? The pump. Yes or no? It can be? It can be, yeah? So simply now, if I need to introduce the controller to the block diagram, it will be here. So this is the controller. Now, the output of the controller, we call it the actuation signal, U of T, or the command signal. Now, the output of the controller is the input to where? To the actuator. Now, sometimes for short, instead of plotting the actuator and the process, the combination between the actuator and the process is actually the plant. We call it the plant. So simply the combination between the process plus the actuator is called the plant. So instead of plotting, let's say, two blocks, I can write one block, and this block is what is called the plant. Now, the controller also simply need a command signal, or let's say a reference signal. Let's assume here I need to do a very simple control. So let's assume that the input to the controller, I will choose it to be the desired level. So let's see now. Someone can say, I can solve this problem with very simple control. And how is that? If you are a good engineer, you can do the math and simply you know the area. And you know, let's say the height. From the area and the height, can you calculate the volume?
Yes.
Yes. Good. So
Yes.
if I know the volume, so from the knowledge of the volume, and if I know the flow rate from the tank, can I calculate how much flow I need to fill the tank and maintain it? Yes or no?
Yes.
Yes. So this is a very simple control problem, by the way, huh? If I know the dimension, if I'm a good engineer, I can do the math and simply I can calculate how much flow I need to pump inside the tank in order to achieve the level, then maintain it, yeah? Yes? So simply this means that let's assume roughly Q out. Who can choose Q out here? Any value? Of course, please respect that my pump, the maximum flow rate is 20 liters per minute. Huh? So let's assume, who can say 5? 2?
5.
Okay, so 5 liters per minute. So someone will say, I can inject here how much? I can start with the maximum 20 liters per minute. Yeah?
Yeah.
So simply let's assume that this tank need 100 liter to fill it until the desired level. According to what? According to our calculation, huh? Yes. So simply, how much or how long I need to operate the pump at full speed? Let's say 20. Here I'm having 100. So this will be what? 5. Huh? But keep in mind, inside the 5, I have what? I have 25, which is what? Drain. Yes. So I need to operate, let's say the pump for 6 minutes. Let's say for 6 minutes, I will have here 120 and 30 here. I will have 90. So simply I need to calculate. Then I will end up with what? I will end up with something like this. So simply, I will end up with a time profile for how much flow I need to pump inside the tank. And let's assume this is the Qn. So I need to pump this one until certain time. Yeah. And you know, we can calculate it. Yeah. So simply 20 multiplied by x minus 5 multiplied by x must equal 100, correct? Yeah. So this will be 15x equal 100, and x will equal to what? 100 over 15. And x now is the time, huh? In second. Do you know what I'm calculating?
متى حيتعبى او نوصل للديزاين تايم؟
Yes, 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 yes. So do you see? It's very simple, huh? So simply now this time here, I know it will be what? 100 over 15. After that, I should maintain Q in to equal to what? Q out. Yes or no?
صحيح.
Yeah. So if this one we decide to be 20 liter per minute, and the Q out was what? 5? It was 5. Should I return to it, or it's 5? So let's try to return to it. It is yeah, it's 5. So it's 5. So let's assume this is the 5. Yeah. And like this. And this one is what? 5 liter. 5 liter per minute. So if you are a good engineer, if you are a graduate from JUST, simply you will achieve to solve this problem, yes or no? Yeah. And if I'm writing the output, this is y of t. I think last time we agreed to use y of t for the actual output, correct? T. So now, if I'm assuming that the tank was fully empty, then I will go from here until this point with this time, I think 100 over 15, yeah? And after that, I will maintain what? The desired level. Yes or no?
Yes.
Good. So simply this is the desired level. So do you see the control is very simple, huh? Yes? Huh? Control is very simple. Cheese of cake, huh? Cheesecake. Yeah, it's very simple. Only you need to what? Only you need to master the math. Then you should put the math in practice with physics. After that, you will be an engineer. Yeah, very simple. Okay. Now, let's assume. Okay, before that. Now, simply this actually, in order to achieve this flow, let's assume that this actually is linearly proportional with the voltage. So this will be from 0 volt. Let's make it easy for me. Let's say until 20 volts. So if I'm having 0 volt, the pump will, the flow rate from the pump will be 0. If I'm having a 20 volt, then the flow rate from the pump is 20 liter per minute. Fair enough? And this is a linear scale, because I'm too old to use non-linear scale. Yes? So simply, if this is correct, who can give me the voltage signal now here? So the voltage signal will take what? Will take the same shape of the Q, yeah? Yes?
Yes, doctor.
So simply here I can add the voltage also, yeah? And this is the beauty if I'm having per unit, by the way. If I'm having per unit, I can plot all the graphs in the same, let's say, axis, yeah? Good. Now let's see. This signal is time based signal, which means that this signal depends only on time, yes or no?
Yes, depends on time.
Yeah. So simply, this means that there's no relation between the actual output and this signal, yes or no? Is this signal changed according to the actual output or according to the desired?
للديزاير.
Yeah, because I need to inject, I did the math, by the way. If I did a mistake in the math, this is something else. But let's assume that I'm good, that I'm passing the calculus in the first stage. So I can do the math, I can calculate, and I'm good. So simply now, U of t, this signal here, the actuation signal now is the voltage, correct? Because the pump is my actuator, and the actuator now need a signal in order to know what to do. And this is actually what? The controller objective to tell, let's say, the actuator what to do. So this control signal is a function of time, is only a function of time, has no relation with the actual output, yes or no?
اكيد دكتور بس ما فهمت.
Okay. Now, U of t is the voltage in this case, yes or no? Because if I need to control the pump, I must change or adjust, let's say, the voltage, yes?
Yes.
Okay. So let's see here, I'm adjusting the voltage based on time. Yes, from zero until 100/15, I'm injecting, let's say, 20 volt, I think, because I use a linear scale. Yep. So this would be 20 volt, yes? After that, I change the voltage, or the voltage is dropped to be what? 5 volt. Why 20 and 5? Simply because I'm using a linear scale, and I'm assuming that the relation between the flow rate and the voltage is linear. So 0 will give me 0 flow rate, and 20 will give me the maximum flow rate, which is the 20 liter per minute, yes? Yeah?
Yes.
So simply this means that the actuation signal, this one, is only a function of time, has no relation with the actual output. Let's output. Yeah? Understood?
Yes, doctor, yes.
Okay. So simply this means that here, the input to the controller now is my desired level. Yeah. Yes. Yep. I need my level to be at certain height. I did the math and I found this is the perfect solution to my problem. Yes or no? Yeah.
يعني دكتور
Yes.
بس خليني احنا عملنا الماث فحسبنا انه عشان تتعبى وحسبنا اللوس اللي هو الخمسة، واذا كان شغال على الماكسيموم هو 20 لتر حتوصل حتتعبى يعني على التايم 100 على 15 صح؟
Yeah. This point.
بعديها حتتعبى بس حيضل في اللوس الخمسة صح؟ عشان هيك
So
كتبت
I should maintain this condition, which we call the steady state condition. Huh? I should maintain the balance. Q in must equal to Q out. Otherwise, the level will be dropped. Or if Q in is greater than Q out, then I will get a level more than the desired. Yes or no?
صحيح.
Actually, here I'm giving, let's say, a perfect solution. There's no overshoot. There's no steady state error. Yes or no?
صحيح.
Yeah, that's good. So this means that you don't need to take a course in control system. If this is the solution, yes or no? Yeah.
Yes,
Now,
sir.
okay. Now let's see. If we agree that the control signal U of t is a function of time, has no relation with the output, this actually what we call the open loop control structure. Yep. So simply this structure is called what? Let's use this one. Huh? The open loop. Why open loop? Because the control signal is a function of time, has no relation with the actual output, which means that if the output change, the control signal will not change. The control signal already predefined. Yes, this signal is predefined.
يعني دكتور زي ما في فيدباك يعني.
Yes, is predefined, which means that with, let's say, with no feedback. Yes. Good to go. Yeah.
ممتاز دكتور.
Okay. So now let's assume for any reason your brother come here and he need to make a joke and change the outlet valve either by increasing or decreasing. Choose increase or decrease.
Increase.
increase.
Increase. Let's assume 10 liter per minute. In this case, your controller can solve the problem. Your controller can react for this change.
لا.
لا.
What you need again to solve the equation. Yeah.
Yes.
And simply this means that the controller cannot react by itself. Yes or no?
صحيح.
So simply this means that actually I need more complicated controller. Other configuration. I need to sense the output. I need to make my controller react in the direction of changing of the output. Yes or no?
Yes.
Yes.
صحيح.
Good. So now let's see. Let's try the following configuration. I will use the same thing here. The tank, my tank. And this is not good. Okay, I think I still need to practice. You know, practice is the solution, huh? Yeah, let's hope. Yeah. Okay. It's like fighting, man. Just a minute. Let's make it in this direction. Or let's make it more elegant, huh? Okay. Okay. Now, let's assume I'm having the same tank, and the same configuration here. I'm having the valve, and still, let's say my brother is playing with the valve. So all the time the Q out is changed, huh? So this is the Q out. And the same thing, I need to maintain, let's say, my level at the following desired level, which is, I think we agreed to call it YD of T, correct? As a definition for the desired output, yeah? And now, one solution, if I need to let's say adjust the control signal according to the actual output, then what I should do? If I need to adjust my controller in favor or in direction with the actual output, the first thing I should sense the actual output. I should measure the actual output. Yes or no?
Sorry.
Yes, Doctor.
مظبوط.
So simply I need to measure. So the simple solution here is the floating ball. I think last time maybe we discussed that, huh? So let's assume that here I'm using the floating ball. And let's assume that the tank has the following flow inside it. Yeah. And now let's assume I will change slightly the configuration in order to highlight the idea. It will be the same. Huh? Then now here I'm having the inlet pipe here. Let's make it. And I need to control the flow, which is the Q in. And the same thing, let's assume that here we have the pump, and the pump will inject the fuel, or let's say the liquid here in this case. And let's assume now what I'm having here, I'm having a valve, and this valve will adjust the gate opening for the gate. Let's make it more attractive. And good. Still here I'm having pump. Still I'm giving a voltage, but now I'm fixing the speed of the pump, let's say. Of pump, and this pump has a protection in order if there's no flow from the pump, it will be turned off. Otherwise, I will burn the pump. And now, according to the actual level, the floating ball will rise or fall, correct? So no. So according now to the actual level, if the actual level increase, then the floating ball will go where? Up, yes?
Sorry.
and if the level is reduced, then the floating ball will go toward the downward direction, yeah? Downward. Yes or no?
Yes.
So now simply see, if the floating ball go up, then the gate, this gate will be reduced, yes or no? Yeah, if the floating ball
Yes.
go up, the
Yes.
gate will be reduced. So simply the flow in will be reduced, yes or no?
Yes.
But if the actual level go down, then the floating ball will go down. Then the gate will increase, the gate opening will increase, yeah? And the QN will what? Will increase. So if the gate opening increased, then QN is also what? Increased. Yeah?
Yes, Doctor.
So simply, this means that if I plot the curve, this is the T, and this is Y of T, and let's assume this is still my desired, maybe I will get something like this one here, like this, yeah? According to the performance here of the valve. Now, let's introduce the valve in the control system. If you noticed,
بس
I will
كده.
recall that the first thing here, do you have a question?
يس هسه بالنسبة للكيرف فوق هسه ممكن انه زي ما انت رسمت يكون طالع عن الديزايرد ليفل مش بالنسبة للفوق هون راح يصل بس للليفل.
No, maybe. Do you know why? Because simply here, the flow rate is proportional to what?
To the level.
To the level, huh?
Yes.
So now, how much Q I'm injecting actually here, I don't know. So maybe I'm injecting more, more fluid. In this case, the gate will be fully closed. Yes.
Yes.
So this means that I'm here. I'm here actually. Huh? Then after that, still the gate is fully closed, but I'm having outlet from the tank, which means that the level will drain until I'm reaching the balance solution, until I'm reaching here a QN equal to what? To the Q out. Yeah. So simply, if you notice here, this means that QN is proportional with Y. Yeah. Or let's say, I would say delta Y, the error signal. Huh? I would say the error signal is proportional with what? With the error signal. If the error is high, yes, then the flow rate will be high. If the error is small, then the flow rate will be small. Correct?
كوريكت. بس انا كان الفكره انه احنا بالكيرف اللي حاطينه هون المفروض باستخدام الفلوتنج بول انه بس يصل للديزايرد راح يسكر، راح يصير في عندنا بالكيو اوت يطلع بعديها باول ما يصير في نقصان الطاوله راح تنزل لتحت، فراح يصير يفتح بمقدار يتناسب مع كميه المي اللي طالع، فراح ما يطلع فوق الديزايرد ليفل، راح يوصل للديزايرد ليفل لانه احنا البول حاطينها بناء على الديزايرد ليفل، يعني راح يقفل على الديزايرد ليفل.
Yeah, but this depends on in multi, let's say, conditions. The first stage is if this one is, let's say, optimistic, which means that I'm calculating all the variable such that when the floating ball reach the desired, then the gate will be fully closed. Yeah.
تمام. هو انا يعني بشبهها هي زي العوامه يعني.
Just a minute. Here I'm having all the time Q out.
Yes.
So this means that if this is the case, this will be your scenario.
بالضبط.
Yeah.
Yes.
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 Now, let's see. You know the floating ball, sometime according to the weight, will be floated somehow, yeah?
Yes.
All the ball will be out, yes?
Yes.
And this actually will depend on what? In the volume of the water and how much, let's say, lifting weight I'm having, correct?
Yes.
So that is sometime if you go to your tank, you will see sometime it is filled until certain point. Another day it will be more slightly increased.
Yes.
Yeah.
Yes.
And it will be maintained there. Why? Because you are not draining in that time. If you are draining, it will be like something like this. Yeah.
Yes.
And I think I told you that this is an example. It can be like the actually in practice, it should be like this.
Exactly.
Yeah. Yeah, because I have here friction, I have time constant. So in general, it's impossible such that I will achieve zero steady state. But simply this is an example to highlight that I can solve this problem using a very simple closed loop configuration. Yes?
Yes.
Oh, good. So now, if I did answer you, let's continue with the block diagram. So now instead of plotting the two blocks, which is the process and the actuator, instead of that, I'm plotting here what? The plant. And recall, the plant is a combination of what? Of the actuator and the process. The output from the plant is the actual level. Yeah. Now, here I'm having a controller. Here I'm having the controller. And remember, the controller is a mechanism in order to tell the actuator what to do. This is the controller. Now, the first question, did I measure the actual output, yes or no? Did I measure?
Yes.
Yes, I did measure the actual output. Actually, the floating ball is measuring, yes, the actual output. So simply here, I need something, we call it sensor. Interesting, this one. Okay. All the time we learn. So this is the sensor. And the sensor is what? Is a device used to measure the physical quantity, let's say, or the process. And convert it to another form useful for controlling. So simply, here I will have the actual output or actual signal here I will have the measured signal, correct? Are they the same? Is the actual signal same as the measured signal?
No.
No, it can be, let's say, different in level or in form, correct? Either I'm scaling, yeah, or I'm changing the form. The actual level is level, height. This can be what? Electrical signal. Now, in our example, in this case, it's actually what? It's height, but simply it's scaled in what? Scaled in magnitude. Then I need to compare the measured signal with the desired output or command signal or reference, let's say. And comparing this means that I need to subtract. I need to subtract in order to generate an error signal. And this is the error signal, E of t. So if this one is y of t, and this one is y measured of t, and this one is y desired of t, and let's assume for simplicity actually that y of t or y measured of t is equal y of t actually. Because in the end of the day, this is an indication of what? Of the actual level. So E of t will be equal to y desired of t minus y of t. And I think last time we stated that the objective of the controller is to minimize the error signal. So if E of t go to 0, as t go to infinity, this means that y of t will equal y desired of t, which means that we are solving what? The control problem. Now, where is the control signal? The control signal, u of t. This is the u of t, correct? The output from the controller, the input to the plant is the control signal. Now, this signal is a function of the actual output, yes or no?
Yes.
Yeah. So simply, this is what we call it the feedback configuration. Feedback control system or the closed loop control system. Let's call it the closed loop control system. Now, let's see. What about if your brother here changed the gate, the outlet valve from, let's say, 5 liter per minute till 0 liter per minute? Still, can the control react?
Yes.
Yes, it can react in one condition, that I don't have flow over the desired. Otherwise, I cannot drain.
Yes.
What about if we change the 5 liter per minute to 10 liter per minute? Your controller can react and adjust the level in order to achieve the desired level, yes or no?
Yes.
Yes.
Good. So simply this is one advantage of the feedback control system or the closed loop control system, such that the closed loop control system can react if there's a changes in the plant, either the dimension, either if we have, let's say, disturbance. For example, for any reason, your brother come and put object inside the tank. Let's assume that this is the object here. Now, this is an external object, correct? Which will take some volume. Yeah? Which means that now the volume is not the same as the volume. Which means now I need to inject less water in order to achieve the desired level. Still, although the open loop can't see that, cannot react according to that, the closed loop can do that. Yeah? Good? Okay. Now, who can give me example from the real life regarding the open loop and the closed loop? Here I will write examples for open loop and here for the closed loop control system. Who can give me examples? from your daily life, something around you. You can see it all the time, maybe.
الكلوزد لوب ممكن طوشت بالتنكات.
Yeah, it's simply the floating ball in the tank, correct? The floating ball in the tank. Or let's say, which is the liquid actually, huh? So the same, huh? Liquid level control. I need another example.
الاير كونديشنر.
Yeah, before that, someone say the street lighting, huh? The street lighting is a closed loop or open loop?
Closed loop.
A closed loop. Do you think that IDCO is measuring the brightness, and according to the brightness, they are lighting or turning off the light, or it's a time base?
لا دكتور حسب الإضاءة لأنه أحيانا بيكون في ضوء شغال بالنهار.
So this means that's not according to the brightness. It's a time base.
لا قصدي الدكتور مثلا بالنهار بيكون في ضوء شغال لأنه مش واصله إضاءة كافية. فممكن إنه الحساس مش واصله ضوء فبتكون closed loop. ما في feedback.
So simply you understand the meaning of the closed loop and the open loop. If I'm measuring something and according to that I'm reacting, this actually was the closed loop. So if they are measuring the brightness and according to their measurement, simply they turn on or turn off the light, this is a closed loop. But if at 6 p.m. all the lights are on and at 4 a.m. all the lights are off, this will be what?
Open
loop. Yeah, good. Another one say that air conditioning system, yeah? The air conditioning system is what? Open loop or closed loop?
Closed.
Yeah, the AC system, huh? This is not the alternating, huh? Air conditioning systems, huh? Who can give me open loop, huh? Of course, the closed loop, the refrigerator is a closed loop. Let's say the driving the car is a closed loop actually. Yes or no? Yeah, of course, because you are observing everything. You are observing the speed and you are adjusting the fuel pedal according to the current speed. So simply this is an example for a closed loop. I need examples for the open loop control from the kitchen. One point.
كأنه غاز.
الغاز. What's the غاز؟
مرات يعني بنسوا داير هم مش بحاجة. يعني ممكن تطلع باللوب يعني ما في شيء يقيس إذا غليت المي خلاص لازم يطفي، أو إنه إذا وصلت مثلا درجة حرارة المي ل 100 لازم يقلل استهلاك الغاز.
So let's make it what? The oven.
Microwave.
The oven, the microwave. The microwave.
بتطفي عند درجة حرارة معينة.
Which is what? The oven or the microwave? ها؟
الميكروويف بس يسخن الأكل جوا بيطفي لحاله.
Are you sure? Now let's see. In the microwave, the object to be controlled is what?
مش التايم بس انت بتحط مثلا دقيقة بضل يشتغل دقيقة.
I need to reach to that point. But simply, in the first stage, I'm asking you, in the microwave, actually the object is what? What I'm controlling?
Temperature of food.
The temperature of the food.
The temperature of the food, yeah? So simply, you are opening the microwave. You are putting your food inside the microwave, and simply after that, you are choosing let's say a course, yeah? 2 minutes, 3 minutes, 4 minutes, yes or no?
Yes.
After finishing that time, are you sure that your food will be warm in the state that it satisfies?
No.
Yes, so this one is not a closed loop, it's an open loop. Yes? Simply why? Because the microwave is not measuring the, let's say, the warmness of the food, the temperature of the food, yeah? The microwave is running according to predefined course. So this is actually an oven, an open loop, huh? The same thing, the oven. Yep. What's that? Yeah, the washing machine is also an open loop. Why the washing machine is open loop? You know, in the washing machine, you have drum, you have motor, you are controlling the speed of the motor. Sometimes the drum is going very fast. Yes or no? Sometimes you are switching between drain, yes, and laundry, hot and warm. But simply the washing machine is still an open loop. Why? Because the objective is what? The objective of the washing machine is, huh?
cleaning clothes. Redefined اللي احنا بنحطه.
The cleaning the dirt from the clothes, correct? Which means that, are you 100% sure after ending the course that your clothes will be clean in a stage that is satisfying you? No, sometimes you will repeat it 2 times. Yes?
Yes.
So this is also an example for what? For an open loop. Now, let's see. In terms of the cost, which one is the most expensive? The closed loop or the open loop?
Closed.
Why?
Closed.
Because it has sensors.
Because I'm having more inputs, I'm having more elements, huh? I'm having sensor, and this sensor will add cost to the system, yes? So in the end of the day, the closed loop will be more expensive than the open loop. Now, in terms of performance, which is better, the open loop or the closed loop?
Closed loop.
Why? Because the closed loop can react to any changes in the process or the plant in general, can react if any disturbance happen to the system. Yes or no?
Yes.
Yes.
So if you are engineer and I need a solution, the first thing you will try the open loop or the closed loop?
open. دكتور حسب المسألة.
According to the
في أشياء ممكن open loop أحسن.
So simply, if you need to sell anything, you need to reduce the cost. Yeah. Reducing the cost, this means that you'll ask yourself in the first stage, can I solve this problem using open loop? Yeah. In one condition, the process by itself must be stable. Yeah. The microwave by itself is stable. Yes or no? The oven by itself is stable. Yes or no? The washing machine by itself is stable. Yes or no? Yes.
Yes.
Yes,
yeah?
of course.
Yes. But simply let's assume that I need to control the car, the orientation and the mobility of the car. Can I design a predefined route and give it to the car and say, go, this is your route? No, it's not. No. Why? Because simply maybe the road will change. Maybe something will interface or interact, let's say, with the car. So this one, for sure, I will go with what? With the closed loop. Now, in general, there's in engineering, we have 2 things we must consider. The cost per performance. The cost per performance. Now, as engineer, you must provide the best performance with the minimum cost. Yes? But keep in mind, if your application is related to other life or your life or to the human lives, in this case, you should put the performance in the first stage. The performance should come in the first stage if the application is directly related to the human life. Yeah? Imagine that if you are designing a controller for a nuclear reactor, and then you will say to yourself, I will reduce the cost by, let's say, using a second-hand sensor. It will cut the cost by, let's say, $100 or $1,000. In this case, no. In this case, you should maintain the performance. Why? Because if anything happened to the reactor, this will be a catastrophe. Yeah, this will be very dangerous. So as engineer, you should have some kind of ethics, how to judge about when you will, let's say that the performance must come at the first stage, after that the cost, or when you say that I can provide a satisfactory performance with a very good or cheap cost. And this actually now the market and the fighting between the companies is actually who can provide the best performance with the, let's say, the minimum cost. Good. Now, if you notice, I use term called stability. Yes? Yes or no?
صحيح.
Yes, doctor.
لما الاوتبوت يكون زي الانبوت كيو ان تساوي كيو اوت.
Let's assume the same thing here. Huh? Let's assume this is the tank, and your brother shut down the valve. So the valve here is fully closed, and you are pumping a water, QN. In this case, and simply you are using, let's say, open loop. Huh? Let's say you are using open loop, which means that QN is a time based system. Yep. So he shut down, and according to your calculation, you will operate the pump, if I still remember, 100/15, 20 liters per minute. After that, you are fixing the flow rate to be 5 liters per minute. Yes or no?
Yes.
Yeah. So, but because your brother is shutting down the outlet, in this case, the water will be overflow from the tank. Yes. Yeah.
Yes.
Now this is actually what we call it instability. Yeah, because the performance or the out become unbounded. Yes. So graphically, if I need to plot this one here, if this is my desired output, now this is actually what we call it unbounded output, which means that it is unstable output. Yeah. Now, what about this response? This one, stable or unstable?
Stable.
Because it's bounded output. Yeah. So this is actually a stable response. Of course, if I need to study the stability, then the input must be stable. So we can say that the system is stable or bounded input, bounded output is stable for all bounded input I'm having a bounded output. In this case, this system is called bounded input, bounded output. Good. Because you cannot say that I will bring hammer, for example, and destroy the chair and say that this chair is unstable. Now here your input is unbounded. Yeah. Now, did you understand the meaning of the stability? For short here, huh?
Yes.
Okay, good. Now, another term. Do you remember I say disturbance? Sometimes I say disturbance. Yeah. when I told you that your brother is coming here and close the outlet, or he throws something inside the tank. Yeah, this actually what we call it disturbance. Huh? What's the disturbance? The disturbance actually is unwanted input. Unwanted input. Now the disturbance can support the input or can resist the input, but simply we don't know the direction and we don't know the magnitude of the disturbance. So neither the direction nor the magnitude of the disturbance is known. Only we know that this disturbance will affect the system. So if I need to plot the closed loop control system where there is a disturbance, now this is U of t. Here will come the disturbance, and I will call it d of t. And here is my plant, and this is y of t. And here I'm assuming this is what we call it unity feedback. In case that the gain of the feedback is equal to 1. And now this will be y desired of t, and this will be the controller here. Yeah. Now this one is the disturbance. And simply here, I'm assuming it's resisting, but it can support, I don't care. But in order to later on analyze the system, in order to find the closed loop response, let's say, I need to assume a direction, and without loss of generality, I will assume it will be minus here. Now, this is called negative feedback. And why we are using negative feedback in the closed loop? Because I need to minimize the error signal. My objective is to make the error signal what? 0 as t go to infinity, which for sure will say that y of t is equal y desired of t, and this will satisfy the objective of the control. Yep. Now let's give the last example for finishing this lecture. Let's assume that I'm driving a car. And I'm controlling the car direction and speed. I need you to specify the basic element of the control system. I need you to specify the input, the output. I need you to specify the sensor and the disturbance. Who can give me the process here as well?
دكتور، هي دعسة البنزين انه نزيد دعسة ونقلل الدعسة.
Just a minute. The process is what? The process is the object to be controlled. Yes?
No.
So simply it's actually the direction and the speed. Yeah.
Okay.
Just very simple. Simply if I'm telling you I will control the temperature in the room, what's the process? You will say what? It's the temperature. If I'm telling you that I will control the level of the liquid, what's the process? It's the level of the liquid. If I'm telling you that I need to control the orientation of the satellite, what's the process? It's the angle or the orientation of the satellite. Yes, it's very simple. Yeah. Yep.
So.
Okay. So now, as process here, we have the direction and we have the speed. So this actually is multi-variable process, correct? Because I'm controlling two things here. Now the actuator, how I can control the direction and how I can control the speed. For the direction, I'm having what?
The steering.
The steering.
Steering.
Yeah, thank you. The steering. And for the speed, what I'm having?
Gas
The
and the
speed button.
pedal.
The engine, let's say. In the end of the day, it will be the engine, huh? Yes?
Yeah.
Yes.
Now, I need the controller, the third element, the controller.
أنا say
The driver, let's say, or the human, unless you are using what? Unless you are using Google Car, the new driver one, huh? The auto driver. Let's say the human or the driver, huh? In both cases, the controller is what? Is the driver. Now, the sensors here are what?
عيني أنا نفسي.
Yeah, the
Observer.
eyes of the human, huh? The eyes of the human. Yeah, of course, actually we have actually speed meter, and this speed meter is measuring the speed, and now it gives indication. Now you are taking this indication and feed it back, correct, to the controller. Yes, correct. Now
صحيح.
what about the disturbance? D of T, the disturbance.
السيارات الثانية الشارع نفسه ممكن يتغير.
So you can say the shape of the road. It can be. What else? What about the wind? Can be disturbance?
ممكن
Yes.
ممكن المطر.
If you are driving against the wind, in this case, you need to consume more fuel. Yes.
صحيح.
If you are driving in the same direction of the wind, then the wind will support you. Yeah. So that's why, if you notice here, I said that the disturbance is input, but this input is unwanted. Why unwanted? Because I don't know the magnitude or the level of this signal, or simply the disturbance cannot be controlled. Can you control the wind?
No.
So that's why we call it what? Disturbance. Good. So simply, this is almost, I think, the end of the first chapter. If you have any question, please ask. If there's any point you cannot understand, please ask. If I skipped any point, please, let's say, remind me about. Everything is clear?
Yes, Doctor.
If yes, who can answer this question? In the first stage, why I need a controller?
دكتور عشان اتحكم بالاكتويتر.
عشان نوصل للديزايرد سبيد او دايركشن.
So in the first stage, why we need a controller, by the way?
عشان أصل للبرفكشن.
So simply, yeah, I can rephrase it as, in order to guide, yeah, a system in order to achieve certain performance, yes? But not only that, to protect the system. Yes, you are controlling the car in order what? Because you need to go from A to Z, yeah, in certain speed, yeah, while protecting yourself and other lives, yes or no?
Yes.
So without controlling this, the car can, let's say, make an accident. Yes. The same thing, the elevator, without controlling the elevator, maybe, of course, the elevator will never go up without motor, without controlling. It will never level at the, let's say, specific or the desired level. Huh? So simply, not only we need a controller to tell the process what to do, or the actuator what to do, but also we need to guide it. Also, we need to protect it. Huh? So simply here, we need a controller to, let's say, achieve certain performance while keeping everything safe and stable. Yeah. Good. Yes.
Yes, doctor.
Okay. Do you have any question?
لا دكتور.
So if no, this will be the end of our course, not course, our lecture, huh? This will be the end of our lecture. And next week, inshallah, I will try to make a pre-recorded video and I will post it before the lecture. So simply you can see it. And after that, I will do the can you hear me now? Can you hear me?
Yes, yes, doctor.
Okay, my laptop actually turned off. Anyway, so we finished this lecture, and next time we'll meet you next lecture, inshallah. So stay safe, huh? Okay. Goodbye. Assalamu alaikum.